Recording. Go.
Okay, so this presentation will be about some features in Postgres and how to use it basically. So I will start sharing a little bit about my philosophy, let's say, if that's a little bit pretentious, but how I would like to lead a tech team, right? So in today's age, most people will start adding things to the tech stack, right? I need a new feature. My database or my X doesn't do it. Let's add another piece of tech, and at the end of the day, you end up with like 10, 12 things on your stack for very simple stuff. And I'm very much opposed to this view of the world. I think we should strive to have as little as we can in the tech stack part of the application. So I would try to minimize the number of things we put on our systems. And with that in mind, I end up exploring lots of things on the database and language, etc. Like I tend to more or less explore and do things in an unorthodox manner. Uh, this is the result of search exploring this talk. I mean, I have a lot of stuff in this document, but we will cover these three topics only. Um, and like I said, the idea is to maybe give Postgres another chunk of your application before you switch to a dedicated database or anything else, right? And this apply to, for instance, for graphs. With if you just need simple stuff in the graph model of things, right? You probably don't need Neo4j or other graph database. That's the point I'm trying to make here. Uh, with that intro out of the way, we can start uh, the presentation itself. So graphs, something happened. I don't know what happened.
Everything is cool.
Okay, I heard some noise. Okay, uh, guys, you can interrupt me. I prefer it that way, other than questions at the end. Okay, I prefer a live audience. Okay. Um, so graphs, I suppose everyone here knows at least a little bit about what is a graph. And knowing that, uh, we are about to explore how to implement it in pure SQL um, without using the programming language, the procedural language, just the query language. Uh, I left here the official documentation for the stuff that I'm using, and this is just a sample exercise that I'm using here. I will show a little bit later. So to start it, we need to understand a couple things before we we can go for the graph thing. So is I mean, I should not ask that, but I will go. This is the with clause from the SQL, and it is generally referred as common table expression or CTE. And in this case, I'm creating a CTE just to return a value, a pair to be precise. And I'm naming this pair A and B, the columns, right? Then I do a select and from this CTE, which you can think of as a in-memory table. It's not that, but you can have this mental model, I guess. Um, and then this limit is not needed right now, but you can, it will be needed later. So just a simple query, 0 and 1. This is not recursive. I'm not using recursion here. And when you think about graphs, we know that we will be iterating over stuff or doing some recursion. And that's the next step. We mark this CTE as recursive, which means now it will behave a little bit differently. It will allow us to reference this name inside the block. And we need basically two components here. The base case, which we already have, and the recursion step, right? So how do we do it? Well, I just did it. The result will be okay. Uh, I don't put the terminator there. So it did not change anything. And can you guess why? Theoretically, it should be an infinite result set because I'm getting the. So
I
how
have a
this?
I have a guess.
Yeah, go for
Because
it.
if it would always return recursively, it would always be 0 and 1. So maybe just
Yeah.
collapsing all these answers into one single entry in the results.
Yes, that's exactly what happens. And that's because I'm using the simple union here. This is a property of a union. And if I want all the results, even if they are duplicates, we do a union all. And in this case, I should limit the result set, right? Because it is a it will go on until my machine breaks. And I limited
I
to
gotta say though,
10
this
entries.
integration with Emacs is very cool.
Yeah, that's really nice. There are some quirks to it, but it's really very cool. Uh, so what we did here. Um, on the recursion part, we are selecting from the previous iteration. This CTE means previous iteration. So we are taking the result from the previous and copying to the next, right? Let's say we want to make a Fibonacci sequence here. We just get the first element on the next iteration is the second element from the previous. Okay? So it's B, the first element. And the second one is the sum of the two previous values. Does this sound alright?
Yeah.
And then here we have it, a Fibonacci sequence with both the 0 and 1 index placed.
So refreshing to see the Fibonacci sequence starts properly from 0 instead of 1.
Yeah, I know there is some debate on the math. I'm no expert. It's just that it's okay for me to do both, and that's the base knowledge we need to do graphs. That's it. Uh, Now we go on for some more advanced stuff, right? Uh, this image is from one of the halves I mentioned previously, and this is pretty much a standard graph for exercise when you're learning it, and it's a weighted digraph. Like so, the you can move in either direction from. It's not a directed graph. I'm just putting it here for completeness sake, I guess. We can consult it later. So this is the graph we are modeling, and how we're modeling it right now is this. I just said it's not a digraph or directed graph, and I'm doing a directed graph because yes. Well, I do a directed graph and insert the edges, right? From 0 to 1, 4, and the weights. And then I do create a view with uh, the reverse. So it make a bidirectional. It has links in both the ways, both ways. Okay?
I have a question. So as far as I can tell, you are duplicating the amount of links, so you can like swap the node that is the source with the destination. So you're
Yes.
purposely increasing the data. Is that better
Yeah.
than trying to make a table with like I don't know a different representation of the graph? Like is making this directed graph and then duplicating it the best approach?
I don't know if it is the best approach. It's the easier one for me.
Well, no, it's definitely the easiest. I can agree with that.
I mean, the code later on gets a little bit complicated if we need to consider the links as both ways.
Ah, okay, okay, okay. That's it.
A little bit more of ands and ors, and
Mhm.
you know,
Okay, okay,
this way it's a little bit simpler. The code later on.
okay. That's cool.
That's that's the ultimate reason, let's say.
And that's a perfect
And
fine reason.
to be honest, I would do it like this. I think
I have no
in
clue.
a
That's why I asked.
real case scenario. Yeah. Oh, that's uncharted territory for me too. It's like just this demo of experience. So
Awesome.
Uh,
I'm,
I can't speak about efficiency because I don't really know enough about Postgres, but from a theoretical perspective, directed graphs are actually more general because you can always just double up and reverse the links to get back to an undirected graph, but you can't really go the other way.
No, yeah,
Yeah.
I completely agree with that, and that's what Jean did. But my first instinct was, wait, you were basically double the rows, right? Immediately.
Yeah. Yeah.
So is there a way that you can like decrease the size of this thing? Maybe, I don't know. And that's why I asked.
It's just a factor up too. Don't worry about it.
Continue, Jean.
And so here's the starting point for this implementation. We have our CTE with our base case. By the way, the problem is on that website is what's the minimum distance from 0 to all the nodes, and the sum of the weights for this path. In this case, like from 0 to 4, you have to go from 0 to 7 to 6 to 5 to 4, and it weights 21. This is the answer from the website. And this is what we are trying to implement here. So the base case, it's just the select on node 0, which is the start. Actually, the interpretation should be uh, from 0 to 7, right? This is a link, and it weighs 8 or 4 in this case. Okay, this is the base case. We need to add the recursion. And let me just check one thing. So I want all the stuff manual. And okay, I should just copy this. And now's the tricky part, right? The recursion. And I need to link. I need to make the path select the nodes from the previous iteration. So I'm mentioning the CTE and doing a alias for type less. And what's the condition of selecting the next nodes, right? The previous iteration says to me what's the link is. Like I'm on 0 and I'm linking to 7. So the next iteration, I need to start from 7. And that's what we are going to do. So g point node, the current node should be equal the previous node, the previous entry link. Does it make sense for you?
Yep.
And I'm limiting the result set because, as you can see in this graph, we can quite easily do cycles. So we could go from 0 to 1, from 0 to 1, from 0 to 1, 0, 1, and be infinite. Please don't say that's not infinite. I know some people get angry when people use infinite in their wrong context. So this is the result set, and it doesn't tell us a lot because we need to know the path it took to reach the destination, right? And the weight is just the weight for this link. It's not the sum yet. Let's do the sum first, which is a little bit easier. So what we do, we just do a plus from previous iteration weights. That's it. We have cumulative weights. Um, how can we check it? Well, we need to know the path in order to do that. And how we do a path? Well, let's start by adding a new field to the base case, which is the I'm using an array starting with the nodes. And what we do on the recursion side, we get the previous path and concatenate with the current node. Basically, that now we almost have the path. It's not complete yet because the actual path here is from 0 to 7. It's not just 0.
I have a question.
Uh, yes.
So my understanding is that we are doing all the possible cases, and then just we're gonna do later a filter on it. Is that what we're doing?
Yes,
Ah,
exactly.
I see.
And so this is not the full path. We need to have the not the full, the true path, let's say. We need to add the current link to the path. In order to do that quickly, I will make a new CTE called SG because I'm a programmer and I don't name things, right? So I'll just get the path plus the current link, concatenate both, and call it full path. So you can see I'm doing a two CTs in the same query, and this is quite common. I don't know if you guys work much with SQL, but that's quite normal when you have complex stuff to do. And my mental model for this, it's sort of like a Unix pipeline. It's not exactly that because you name things and you can call call it later by name, right? So it's not exactly a pipeline, but the like you create uh, intermediate result sets to work on. And now we reference this new CT, and it has the full path. From 0 to 7, the cost is 8. From like this one. From 0 to 1 to 2 to 3, the cost is 19. And we can do it here. 0 to 1 to 2. That's 12. Plus 7 to 3. That's 19. That's the summation. Okay? Um, so there is something peculiar. You perhaps noticed that we are having cycles that I mentioned before, like this one. It goes from 0 to 7 to 0. And generally speaking, you don't care for cycles. You want to eliminate them from the result set. There is, of course, there must be some business rules that want cycles, but for this instance, we don't. Um, how can we deal with it? Well, let's just create a new field as starting as false. This will be used to know if we reach a cycle. And how do we check it on the recursive side? We get the current link and check if it is equal to any of the previous iteration path. Does the current link exists in the path? Yes or no? That's what this field is telling me. Then I am using this as a condition. So I don't want anything that returns true in this case, which means no cycles will be returned. Okay, so far?
Yep. I would
Then
never
I will
bet
have,
that you can do this in Postgres though. This is really cool.
yeah. So now I don't have any cycles. It's just uh, normal data, let's say. Uh, another, I don't, I won't use it here, but we can do uh, the depths, for instance, um, quite easily.
I mean, you can,
Now we
but you
have,
can just grab the length of the path if you want that data, don't
yeah,
you?
yeah, yeah, for sure. But maybe this could be more performatic, I guess. I don't know. Um, then we could do like I want just stuff that it's below or bigger than depth 5, for instance, and returns this stuff. But of course, we can do the, I think it's array length or something like that. But then we have to do -1, I think. Um, and depth is a little bit clear uh, uh, on the intention, I think. So the next step, okay, we don't have cycles anymore, and we actually did it already. That's fun. How I know we did it? Let's check. For instance,
I don't think we
we
did though.
want. I think we
Because
did it.
no, I think we don't because there are many there's more than one path. And I understood that we want the one with the least amount of weight or the maximum amount of weight. We're gonna have to filter
Yeah.
things out.
Yes, that's the next step.
Cool.
Uh, so let's say I want to check this case, right? From 0 to 3. I just filter where the end link equals 3. And that's all the results that starts from 0 and ends up on 3. So that's all the results. Limited by 10 here, right? But you get it. So we want the minimum. What we do? Order by weights. And the minimum one is the first line, 19. And it's 0, 1, 2, 3. And 0, 1, 2, 3, 19. Let's try to do this table uh, with the query. That's one it's on improvisation, so bear with me. I want the should I do aware? I think not. I want the weight for sure. The path for sure. And the link probably. And now the tricky parts. I want the whole number over partition by link, I guess. Order by weights. So what I'm doing here, uh, I'm numbering, uh, indexing would be the better term, I think. The results by link. So each time the link changes, it starts from 1 again, and it's ordered by the weight in ascending order. So uh, I can do the next step now, which
Okay, so we're gonna use
is
shoe selects. I was wondering if you would use that. Okay. One to group them and
weights.
another one to filter them, I guess.
Yeah, it's not group. I'm quote unquote classifying it.
Oh,
Let's
okay.
say,
Yeah, that works.
and then I'm getting the first one, which should be the minimum weight. And if I did everything correctly, I can order just to have it. So here it is. Appears to be correct.
Yeah, it is.
That's cool, right?
Yeah, that's really cool.
Very messy right now, the code, but okay, I guess.
When I saw it the first time, I was really shocked. This, I mean, it's so crazy that you can do this in Postgres, right? You don't even imagine this.
It's not only Postgres, to be honest. Other other vendors do it too, and even Microsoft SQL Server is even better, I guess. They
It
have,
is. It is
yeah,
really
they
cool.
have.
No, I don't know if they have it. It is really cool, but I think we have some trade-offs to talk about. But I'm gonna ask that after you're done.
I'm on
Uh,
this part. I'm done. Please
Oh,
go on.
okay, go Marin first.
yeah, relational programming, very cool. It's just a shame that they standardized on SQL. That's like the worst possible relational language you can imagine.
I think
I think
having
this would
none
look
is
better.
worse.
Yeah, I think this would look way better in something like Prolog or something.
Yeah, I understand
But
that.
yeah, it's very nice that you can do this though. Um, Very powerful model.
Yeah,
Yeah. So my question is the following. So you started your talk talking about dependencies, right? That dependencies is something that we need to be really careful about because people are including libraries to define if a number is odd or even nowadays. So
yeah.
we need to be very careful with that, and
That's
that's cool.
that's not even a joke.
No, yeah, it is not a joke, by the way. It is not a joke. Like millions of downloads in npm or something. And my question to you is the following. So in this particular problem, we solved it in a very grug way. I think the best term is grug to describe the way that we solved it. We didn't use any fancy algorithms that are available to solve this particular problem, right? So you had
Yeah.
to incur into the the exhaustive solution, and
Oh,
you judge that as worth it to not include a dependency, right? Because that's the entire argument. Instead of adding a dependency, you can just do this. Do you have
yes.
a situation that maybe is familiar to you, that you know that okay, this problem got too. It's not worth it to do with Postgres anymore. It's now time for a dependency. Because, for instance, this
I
is not
see.
the programming language based on SQL, right? Which is, as you probably know, can break stuff. It's not. It can break relational model, all that stuff, but it can do more stuff, right? So, for instance, let's say that I want you to use a more performant and more efficient algorithm to solve this problem. Would you use the procedural language for SQL or add a new dependency, or do it like this?
I mean, it's not if you go on about this and think really, really hard about this problem. When you add another database, for instance, what are you doing? You are breaking the source of truth. You now have, you might have still just one, and if you still have just one, what you have? A integration for the new database, and that has to be developed. It's not freely available. This is one part of the cost of adding new tech stuff to your stack.
No, of course.
Um,
I'm not denying that there is a cost, right? When you add an extra dependency, you do not own that. You're gonna have to maintain it and keep an eye on the updates to see if things break. That's cool.
so
We are aware of that.
yeah,
But what if it's a hassle to do this problem in pure SQL efficiently?
yeah. That's where I'm getting at. Eventually, you might have such a crazy ask query that you cannot maintain anymore.
Yeah.
It's too much. And well, I think that's personal. I don't think that's something objective you can say. Uh, I know a lot of people that would not tolerate this level of queries I showed, and I'm perfectly fine with that. I would put this in production and live happily with it, and maintaining it. So that's, in my opinion, personal. And being personal, it's like I can't answer for everyone. So for
Sure.
me, it would be, I mean, we I tried everything I know and studied and did a lot of stuff and still can do the SLA for instance for a single query or a single response, right? And maybe that's when I'm reaching for new stuff. I have exhausted what I already have.
Okay, that's a valid answer. I am also totally fine with this particular query that we got there. I understand that if you're not familiar with SQL or familiar even with the relational model in any degree, you would find
Yeah,
this a little bit hard to maintain.
yeah.
Uh, but I can see being personal because this is fine and it works for our problem. But I was more like imagining at which point this is too hairy to handle, right? Like maybe if you have 5 selects in a single query, is that enough? 10, 15?
That's very subjective.
Yeah.
Can't. In my opinion, you you can't have this kind of tool. In my opinion,
Okay.
that's just dumb. Uh, it's like the how many arguments a function should have, bro. That's stupid. If a function needs 7 arguments, it will have 7 arguments.
Ooh, but that's a that particular example that you chose is a particularly interesting one because you
I
can always
I
argue
I,
that
I
if you have 7, you could combine them in a struct. Why not?
but you're just moving the mess. It's not solving the problem.
No, 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 but the
That's the
mess is
point.
the problem. We are arguing that it's difficult to handle because it's a mess. So the mess by itself is the problem.
If, what's the difference
Um,
between creating a struct just before calling a function and passing the values? It's no different for me.
The way I look at it
That
is that creating a struct is the right thing to do, but not necessarily because the arguments are together.
I agree.
Rather, it's because they are now labeled. The labels help a lot.
Yeah.
so that's something to discuss in another
Yeah, no, but but
another time.
this particular
But I
example that
don't
you
agree.
chose is a different thread of thought, because I think if the code is a mess and you have 7 arguments, this is only an extra motivation. You should have better motivations to make a struct out of that. But having a mess is a valid motivation. Anyway, you answered my question. I agree. It's very complicated to draw the line in which let's add a new extra dependency, let's not, because we don't own that, and we're gonna have to maintain that and pay attention to the versioning and all that stuff.
Yeah.
And that's always not fun. Uh, so yeah.
Oh, I forgot something that I can show you just from just for fun. Some of the stuff that I just did here, it's already implemented in the standard. I mean, it's the standard or is Postgres? I don't know. Might be just Postgres. Uh, I don't remember exactly the syntax, so this one, cycle detection. It has a special syntax for this. Almost got it. So I'm checking for cycles using nodes. If it is a cycle, I will set this variable, this column, using this one that it's created by the runtime, let's say. And okay, this does not need to exist anymore. And then these 2 columns are created by Postgres itself. I don't need to worry about it. That's one thing that it can do for me. And it does not eliminate the cycles from the result set. We can check the cycles. If we don't want it, I just negate it, right? And there is another thing that I don't remember the syntax from my head, which is the order of navigation on the graph.
Wow, they added a lot of stuff to do this.
Yeah. And so maybe that's before, I don't know. Yeah. And okay, that does. Perhaps I can use the same variable. Never tried it. No. And then I can do like depth first, say, or breadth. So I can choose what I do. And it's a degree of control, right? But it's not fully.
Yeah.
You don't control fully.
Okay.
But it's really cool that this exists, I think.
Oh yeah, you can do a lot with
You don't,
graphs. A lot of things are graphs. So
yeah.
okay.
Oh, I
So
was planning to do more stuff, but I think we should end up for just graphs on this one.
sure, you were the boss.
Use will take a lot of time to
We can
equal to
schedule
this
another
one,
day.
I think. Yeah.
Okay, so I'm gonna finish the recording
So
now.